and I very much appreciate the opportunity to come and talk to you folks. I'm only going to talk about undergraduates. That's my world. It's the only thing I care about. So hopefully I will give you a different perspective maybe than some of the other speakers. Winona State is in southeastern Minnesota. We have about 7,000 students. We have a program in data science and we have a program in statistics. We have about 50 majors in statistics and we have about 25 in data science. We hired our first faculty member in data science who's going to start here in about a month. If you scale that up, I looked at the University of Minnesota has about 30,000 undergraduates. Purdue has about 30,000 undergraduates. If you scale that, we'd have 35 faculty and 325 majors. So given our size, we're maybe on par with some of those.
We have 325 majors, but we don't have 35 faculty.
We've been very blessed, our faculty. We have 8 faculty members in our group, or whatever you want to call it. We are in the Department of Mathematics and Statistics, so we do share those resources. Current undergraduate statistics program started about 30 years ago. A couple of individuals, we have one of those faculty members still, he's getting very close to retirement, but very happy that they did what they did so long ago. Nearly half of our graduates in statistics now attend graduate programs of some sort. So that program is a very traditional program. It is geared towards undergrads, but those individuals definitely have, I mean, we push those pretty hard that if you want to be, if you want to go places, it's probably advantageous to go get a master's degree. And several of those over the years have went and got PhDs as well. I think the motto that a faculty member before myself, and then certainly myself, I've been there 14 years, is we need to keep that curriculum very current. We don't have an introductory course anymore, we have an introductory year. Roxy Peck mentioned that about 4 or 5 years ago. Totally agree. Why does calculus get 3 semesters? For calculus? You could probably do that in 1.5. No, I don't know. I don't teach calculus. Well, let's stop saying introductory course. You can get so much further if you start thinking about curriculum. Think about twice as much time as you would have with most of those students. So we have an introductory year. Some other things that we've made just changes over time. We don't have a survey sampling course anymore. That kind of went to the wayside. We now have a study design course. That's not a NOVA. It's before a NOVA, and all we're talking about is how to set up studies. It's right after their introductory year. It's the first course after their introductory year. So things like confounding, lurking, ethics is in there. So we have discussions about ethics before they ever see regression or analysis of variance. We have things like supervised and unsupervised learning now, so our multivariate and our non-parametric course kind of have gone away for some of those more trendy type courses. And then professional skill development is a big part of what we do. It's becoming a bigger part of what we do. We actually have, totally agree with Michael that has to come through all the courses, but we also have a course just on professional skill development. Our last program review was in 2010. There's several things that were brought up, but one of them that I want to concentrate on here is, are we sufficiently training students for unemployment and or for graduate school? So I think the point was that our graduates, so we have half of them that we basically send to graduate school. The other half, we're finding employment as quickly as we thought they should have. Okay, so they were finding employment, but it was taking 3 months, or maybe 5 months. They almost all go up to the Twin Cities, which is 100 miles away, so that's where they end up, most of them. Some down to Chicago, some over to Mayo Clinic. We have a good connection with Mayo Clinic. But we were really worried about that employment part because we do a little bit better on that employment part. So this is what we did. This is a lot. You can't read that, so I'm just going to explain it. And it's very much, I don't know if Michael's still here, if he left. I wish I would have talked to Michael. We basically did a lot of what Michael did. 3 years later, 5 years later, whatever it was, 2011, I guess. So here's what we went through. We went to the United States Conference on Teaching Statistics, and we just asked people, what skills do you think people need to go into employment, and what skills do you think people need to go into graduate school? Just laid out there. Okay, we also did some of that, let's see here. So that's what we started with. And we started to find out that those didn't line up real well. So we said, okay, that's great, but what do we know about what they need out in employment? So what we did is we took, I think it was 5 different sectors of businesses, and we went and interviewed them one-on-one about what they wanted in their new hires. Okay? And we basically just gave them a blank piece of paper. Actually, the first interview, I remember that one very vividly. We took all of our course lists, put that down in front of them, and said, what courses would you like your new hires to have? And the individual didn't look at that list the entire time. That doesn't make any sense to them. They don't care what courses. All they care about is the skill set that you're giving these students. Okay, so the next interview, we didn't give them the course list because we now look a little bit smarter. So we just went in and said, all right, what skills do you think you need in a new hire? We're talking entry-level positions. I'm not talking about the PhDs, and all I care about is undergrad. That's my complete frame of reference. Okay, we put all that together. And we really started scratching our heads a little bit because we have to live in course land. Okay, so it was very eye-opening to take skill sets and try to align those with courses, very much like Michael was talking about. So we kind of mocked up, in 2012, we kind of mocked up a degree that is basically our statistics degree just tweaked. Okay, that's where we were at in 2012, went to JSM, got a lot of feedback on that. We also took, kind of throughout 2013, spent a lot of time talking with the, just say the business community, the analytics community, whatever acronym you want to use, I guess. We went to the conference on statistical practice, and presented it there, because that's a different, JSM's very nice, but there's a different focus at CSP. If you haven't gone to those conferences, strongly encourage it, very nice conference. Then we went back to JSM the next year and said, okay, we really need a second kind of degree. We don't really want to ruin what we got going with the statistics. Okay, so there was enough difference between those two that we ended up creating kind of a revised major, which we started calling it data science. And then we again got feedback. Throughout that time, we went to the job postings just like Michael, and started to figure out things, from those job postings to try to augment what we were trying to put together. Finally, towards the end there, in September 2013, we had a data science expert come in, talked with we had to convince the university at that point that we were doing what we needed to be done. April 2015, we actually formally launched it. Jessica Utz was kind enough to come and help us launch that program, so I'm very grateful for that. And then this past month, I guess, or a month and a half ago, we had our first graduate. Took a long time. I bet that could have taken probably at least a year and a half off of that if I would have just had a conversation with Michael. But yeah, that's how it came about. Another thing that we started back 5 years ago is the Midwest Undergraduate Data Analytics Competition. You've probably not heard of that, and I apologize if you haven't. It's very, very cool. It's essentially like DataFest. DataFest was started by Rob Gould in 2011. So it was quite small at that point. DataFest has grown quite a bit. Some differences between DataFest and us is MUDAC is not, and I realize DataFest isn't necessarily this, but it's more centered at a university. So Purdue might have a DataFest, okay, or Duke has a DataFest, and I think they get folks from high school, I think, and they get folks from other schools. The MUDAC gets, I think we had 17 different universities. Okay, which might not be a big thing, but we're in Minnesota. Okay, the closest school to us is 2 hours away. Well, not 2 hours, I guess. Luther's an hour away. So we get a lot of draw from around the area for that. They have 24 hours. The biggest thing, and I think DataFest is going to evolve into this more and more and more, is that the professional development for the students. And I'm not just talking about analyzing data and presenting that stuff to to say industry or corporate partners. I'm talking about we should be having panel discussions about what our profession is about to these students. So those types of things need to be happening at these competitions, okay? At least I believe strongly they should. In the last 3 years, I think, we've had, 2 years, we've had an on-site job fair. So, will they come? Yes. Do employers come on a Sunday afternoon? Definitely. Will employers pay a lot of money to come and get access to those students? Yeah. I mean, that's well worth their time. The other thing is we only limit to, you can only have 8 people from a school. This thing has grown quite a bit. We're a small school, so we have that restriction. So we're trying to get, and that's just the way it operates. This year I made 175 name tags, which again isn't that big a deal, but we're talking about a little big school. And so the budget is $12,500. Another key component of this is an organization called Mini Analytics. Mini Analytics is an organization of, they told me they're up to 7,000 analysts, data scientists, statisticians, et cetera, in the Twin Cities. Is there 7,000 analysts in the Twin Cities?
Probably more.
But maybe not PhD statisticians, but people that work with data and find a lot of value in being associated with that organization. We are associated with that organization. And we need to be associated with these types of organizations. That's where our students are going to go. If you don't associate yourself with these analytic communities that are out there, I think we're going to be left in the dust in a short time. Every city around the country has meetups. Are your faculty going to those meetups? Okay. They need to be if they're not. Okay. A couple of things, 3 things I guess MEDAC has convinced us. Undergraduates can do data science. Undergraduates can't do statistics. Well, yes, they can. We've been doing it for 25 years. They'll never find a job. Yes, they can find jobs. So you're not going to convince me that undergraduates can't do data science. They can't do it at the level of a PhD. Don't get me wrong. I'm not saying that, but they can do data science. Strong demand exists for those that possess these skills. And developing a comprehensive undergraduate data science program should be done. I was talking to colleagues before I came out here, and I said, you know what, if somebody at a smaller school wanted to start a program, should they start one in statistics or should they start one in data science? And I think the answer is, and colleagues agree, it's probably going to be in data science. So if you're going to start from scratch, go the data science path. Too many times in my last 14 years, I have heard graduate programs and people, faculty in graduate programs, graduate directors, tell me that they don't want their students to have undergraduates in statistics. They're going into a graduate program in statistics. No, we'll teach them that. You just do them. Can you imagine any other discipline that does that? Except maybe law, medical school has that. But can you imagine a biology department saying you don't really need an undergrad in biology to study biology? Sounds kind of weird to me. I think we need to stop saying that. Of course, my world is undergraduates. That's all I care about. And when you say that, that hurts my feelings. Okay, so here's what came out of a lot of that, is this three-legged stool. Okay, and I've seen the Venn diagrams, and I appreciate all that, but I kind of like the stool analogy. And when I say data science, I'm talking about the broad part of data science here. So we want that broad part, and we also want the STEM part. Okay, in our world, for us, we definitely think that STEM should be statistics. All right, but in data science, that STEM could be all sorts of different things. That STEM could be computing, could be computer science. It might be domain knowledge, computational biologists. Okay, we got to allow that STEM or that handle or whatever you want to call it to be a variety of things. It's going to be in data. It is in data science. Now, we as statisticians want it to be statistics because that's what we hold dear to us. And if we hold on to that, it's going to protect us from anything else that comes down on us. But we got to allow that to be other things. You have to in data science. We had a speaker from Ryan Swanstrom from Microsoft. He's a great speaker if you ever want to bring him onto campus and talk about data science. He does a great job. He kind of defined, I think it was like 5 or 6 different jobs that data scientists can do. Okay, data science has sub areas in it now. You know, like there's people that just do visualization. There's people that just do writing. Right? Chris yesterday said they just hire people to write their stuff. So they just got writers or people that just do visualization type things. Tell the story, I guess is maybe the best way to say it. Okay, there's people that got to take and develop software engineering. Okay, there's a whole variety of things now underneath data science. So it's way further ahead than what most of us are thinking. So I think the important part when I talk about data science, and this really came out in those interviews, is this balance that you need to have between these three elements: the analytical part, the computational part, and the domain and professional skills. It really should be 33%, 33%, 33%. I've seen way too many programs in the last just being developed, way too much. Ryan and I were talking about this. Way too much that statistics programs are just rebranding themselves as data science programs. That's really bad. That's just going to confuse things a lot. Okay, we are not data science. What does our curriculum look like then? We have a year of computer science. We have an introduction to computer science, which is basically an exposure to algorithmic thinking. We have a year-long sequence, and then we have a database course. We also have a course in data management. That course has actually been around since I've been at Winona State, 14 years. Where that course came from, it's from the Mayo Clinic, because a lot of our undergraduates in statistics were going to the Mayo Clinic and work. Okay, so they needed computing skills before they could be employed at the Mayo Clinic. The first week was just go in and take this course. Okay, 8 hours, 5 days, just get your SAS and your R and stuff out of the way. So we actually borrowed it, stole it from the Mayo Clinic and said, okay, we can do this for you. All right, so that one's been around for a long, long time. That's basically a data science type course. The analytical part is a year-long sequence in statistics and then also a modeling course. 9 credits. 9 credits in stats. That was really scary to hear the first 15 times that we were talking to the people that were going to hire our students. You know, what about the math stat? They need that, right? Because that's really fun stuff. They don't need that. What about multivariate? Because that's my baby. I like that. No, multivariate. Not if you're going to fit everything else in. We have a year-long sequence in data science. We do have a math requirement, applied calc or calculus is one of those. And then we have the domain and professional skills. The way we set up our domain, interdisciplinary domain component, is you can pick any discipline you want. It's a little bit unique. We made the registrar's office very upset with that. College of Charleston, for example, is the first undergraduate data science program in the country. They have, I think it's up to 14 different domain-specific areas that you can, go get courses in. We just didn't want to deal with having to, what courses go in there? Are we going to allow that domain or not? So we just said, you know what, you can pick any domain you want. You want to do data science and art? More power to you. You want to do data science and library science? Cool beans. So you can pick whatever you want. And then we had courses. We now have 2 courses actually in professional skill development, and then we have that, obviously, a project or internship. That keeps coming up, doesn't it? You know what an API is? I don't need hands. Do you know what SQL is? If you don't know SQL, that's okay. There's something called no SQL. So if you don't know SQL, you'll be safe. Could you take a very simple web page, just take some data in, put it into a MySQL database, flip it back out to a web page, do a little Google chart, maybe with some JavaScript on it. Can you do that in the next 30 minutes? This is like basic stuff to data science. This is like t-test to us. Chi-square test. It's not fun to hear what Chris Wiggins had to say earlier. I pretty much agree with what Chris is saying. It's not fun to hear that. I've heard it, I ignored it for so long, but if you just keep hearing it, okay, I guess. If you can't beat them, join them. I don't know, maybe that's bad, but Capital One changed their name. What'd they do yesterday? What he told us, right? No, that's Capital One, so maybe they changed their name from statistics group, the statistics group to the data science group. That should be very alarming. Maybe not, maybe we don't really care about Capital One. Okay, or what Chris had to say, or whatever. Chris also said that he hires statisticians because the feature selection and being able to interpret things, very important. Did anybody ask how many statisticians? I did after he left, or afterwards. Not very many. He's got a lot of people under him. He's got some. He's got some of us. He doesn't have a lot of us. Okay? We need to stop saying that data science is our stuff. That ship is already done. It's not quite up to sea, but it's pretty darn close. Maybe in the harbor. You're not going to be able to swim to it anymore. It's further than I can swim. You can get on a speedboat somehow and get there real quick. You might be able to hang on to the side of it, but you're going to have to figure out how to be part of it, especially at the bigger universities. I'm really lucky at Winona State University. We're pretty small. We have 8 faculty, 7 at the time when we developed this. We're pretty flexible. If we want to get stuff done, we can get it done fairly quickly. Do we have big turf wars? No. Do we have big grants that we have to worry about? Absolutely not. My goal is undergraduate statistics, and all I really care about is the people that are going to go out and get employed. I like to create people like myself, but the fact of the matter is I think it's about 1 out of every 4. For every 1 person that goes to graduate school, we have 4 others that don't out there in our society. We spend way too much time worrying about that 1 that goes to graduate school. There's 10 rows in here, and I'm so just you people. I can't just teach to you people. I mean, we need to be thinking about those going out to trying to get employment. Maybe not necessarily at the undergraduate level. If you're not dealing with undergraduates, that's fine. But you need to be turning out master students that can do these jobs. Otherwise, somebody else is. Can't shortchange any of it. You cannot have computation without databases or whatever. Don't try to have shortcuts. Don't allow yourself to have shortcuts. We like our own classes to run. It'd be great if I could have 5 courses listed under statistics, because then I could help ensure that they're going to run semester after semester after semester. It's really hard to hold back on that. 1/3, 1/3, 1/3. Three-legged stool does not work. This works, I think, because of the balance, as I just said. Because we think about developing skills very much like Michael had said. It's not a curriculum that, I mean, it is. It is. It's a curriculum that we just check the courses off. But that's because of the structure that the university puts on us. We could not, no way at Winona State could we have it sit outside of a department. The university's been working on that for, probably 8 years now. How do we have programs sit outside departments? 8 years to figure that out? Are you kidding me? And I go to a lot of those meetings. I'm on our curriculum committee. It just ain't gonna happen. It's not quickly. Okay? So we had to put it into some department. And it sits in our department, but computer science is definitely a big part of that. Students got to do. They've got to be doing. Okay? Especially, this is true at any level. I think it's especially true at undergraduates. Undergraduates have to convince employers of what they can do. Employers aren't ready for undergraduate data science students. They're not ready for undergraduate statistics students neither. Okay, because almost every single job application or job description that I see, job posting that I see, it says an MS in statistics. Now if you push back a little bit and say, okay, what do you want out of an MS in statistics, they'll rattle off a bunch of stuff in which we try to explain we can accomplish that at an undergraduate level. They're not going to be as mature as you want. Remember, I'm still dealing with 21-year-olds, so sorry, they're not going to be as mature as a 25-year-old. But they can do many things, and we've proven that for 25 years. But they have to convince the employers of what they can do, because employers don't know. That means your students have to be on GitHub. They have to be sharing their code. They have to have portfolios out there of the work that they've done. We have a student out, actually at Hilton out here in DC. He got his internship because of a Tableau visualization that he did in our data viz class. He said the interview was going along okay, but I really couldn't convince him of what I knew. And he said, oh yeah, we use Tableau. He asked to use Tableau. Oh yeah, we use that in a class, a data viz class. He said the tone of that conversation changed within 30 seconds of getting that email and that link. I said, okay, now I see what you can do. It's got to be right in front of you. It's not good enough anymore to look at transcripts and believe that they have the knowledge that we supposedly say that they have. They got to prove that. That I think is especially true at the undergraduate level. So that professional skill development class that we were talking about, that's what we help them with. Marketing themselves, branding themselves, telling them that they can't look for statistician in a job title when they're looking. They don't know that. All right, that's all I got, I guess. Well, any questions? Yeah.
So, I would love to have some discussion, actually it was a question I asked yesterday, but we got to be real. So, I've heard different opinions about, in fact, mathematical statistics came up, earlier today as a topic that was maybe not real popular. Excuse me. But, so the question is, to what extent do we need that? Earlier today, I think there was a string of topics, and maximum likelihood was actually at the end of it. So if we think that data scientists need to be able to quantify uncertainty, we've talked a lot about that in this discussion the last couple of days, to what extent do we need to have a higher level of mathematics and statistics than you have described? And again, maybe there's a number of people in the room that want to chime in on that, but certainly we should start.
So, we're trying to train undergraduates. So I would love to teach them math stat. Our math stat course is, what do we have this semester? 15, something like that. That's, many of you probably wish you had only 15. But that's close to being cut off. Like, we're not going to offer that. So it'd be really great to say, our data science people need to go take math stat. That would be fine. But they also, I only have so many credits.
Right.
And I can guarantee you that if they don't know SQL, that's a much bigger problem than that. So it's just that I got to get it down to a manageable number of credits. Now they can do that in their electives if they want. So if they want to be kind of more stat focused, that's okay. We count those as that, but it's not in that core analytical part.
You might want to take a look at Data 8 at Berkeley. Michael Jordan has a big role in picking this class where they teach uncertainty from example. So it's very bootstrap based and they get people to understand the concept of uncertainty and all from example.
Yeah, he has a good book about data computing. I don't know the exact title of it, but he's teaching, I don't want to say basically introductory statistics, but a lot of he's doing it from a data science perspective, certainly.
So you can go to data8.org.
Yeah. Yeah.
How many students go to the graduate school and which program they go?
For the statistics program now, that's what because we don't have graduates. We have graduates, but they haven't decided to go to graduate school in data science. So for the statistics program, we've sent them all over the place. So University of Minnesota, Iowa State, University of Iowa, Virginia Commonwealth, that's kind of all over. I think we have, I don't know how many, we're pushing 100 graduates that have gone into graduate school over the last 10, 12 years or whatever it is. So somehow we got to get them to donate more money. They are making a lot of money. If anybody has any ideas on how to improve alumni relations, let me know. I can tell you that lots of questions were come up about who's going to teach this stuff. And we just said, we'll figure it out. So I've taught the intro to data science course twice now. Am I a trained data scientist? Absolutely not. I'm a trained statistician. And I hope in 5 years we have 3 other data scientists that can do that for us. But we weren't willing to wait because that ship was going.